Hi there. In this video, we will learn about the estimation of VES production function in Eviews, that is the variable elasticity of substitution production function. We have understood the concept of variable elasticity of substitution production function before, and we have used this form of it when we calculated its share, its marginal product, and the equilibrium condition. However, in this video, we will use an alternative form of VES production function, which is attributed to Ferguson and Logan. These are more friendly when it comes to estimation, so this is why we are using this form. Before we go to it, I encourage you to subscribe if you haven't, and you may click the bell icon so that you get all of this informative material on quantitative economics and research, and you may also like it if you find it useful. So now let's come to the subject matter of this video. It is basically the form that we have borrowed from these references. And here you can see it's a simple multiplicative form, which if we subject to natural logarithmic process, it will give us a form which is less intricate and easily estimable. This form, however, you can see has these bars, which can be quite difficult to estimate when we use the regression techniques. A little bit of adjustments are done here. If we focus on this form, there is a possibility of explaining this term, which is small k, which is actually the capital to labor ratio. So in this step, we have explained that this is capital to labor ratio. Another simplification that we can do is we can decompose this power of labor, and once we do this, it appears like this, and then this labor can go into the denominator of the term on the left hand side. This will leave this term on this side, and we can reciprocalize this labor, and its power will become alpha. Once it is done, we can now rearrange it in this form, which has this whole power of alpha. Now it is quite similar when it comes to these two terms. Both of them have capital to labor ratio. The next thing that we can do is to take the natural logarithm in it, and when we do, we get this expression. And now what we are going to do is to use Eviews, and a little bit of commands will be used in it. Just to highlight this variable, that is t, time variable here is mentioned. Now let's come to the Eviews side of the things. We are going to use fully modified ordinary scale, that is FMOLS, because it is superior to the simple OLS, and it can help us to mitigate the problem of serial correlation. We have to use this because this is a time series data, and in the time series data, serial correlation is nothing unusual. So there are a few commands that we will run in the beginning, because the given data will be in terms of output, labor, and capital, and time. For time, we can generate serial number, that is for the first time period, t will be equal to 1. For the second time period, it will be equal to 2, and so on. But we have to make these adjustments because we do not have the value, that is this ratio and this ratio, and also the natural logarithm have to be calculated. So here you can see the command is generate, where there is an abbreviation of it, GENR, and we are calculating the ratio of output and labor, and here you can see this is how it is getting calculated. This is the natural log of it, and then we calculate the capital to labor ratio, and then this is the natural log of it. And these are the symbols that we are using on the left hand side for the new generated variables. And the most important command is this, that is coint_reg. It basically shows that we are going to calculate the cointegration regression equations. This is why it is not simple reg, it is coint_reg. This is a portmanteau of these two words, that is coint and reg. Then we have the dependent variable, which is the natural log of the ratio of Q and L. Here we can see. And then we have the independent variables, that is time variable. As you can see, the time variable, this will represent the intercept. This will be the natural log of the capital to labor ratio, and this will be the capital to labor ratio. These are the three independent variables that we will use in it. So simply by using these commands, we can estimate the VES production function with this time series data. So now we are in Eviews, and you can see the data is here. We have already opened this data, and we can now run the commands one by one. And here, this is the first command that I showed you, and as soon as I clicked it, it is now the output. QL is generated. And now the natural log of QL, this is the command, pressing enter, and it is also calculated. This is the next command to calculate the capital to labor ratio, and pressing enter, it is calculated. And finally, this is the natural log of the capital to labor ratio. As soon as I will press enter button, it will be calculated. As you can see, it is now visible in the data. Now we have calculated all those variables that are required for this form of the VES production function. Finally, we will do this, that is, we will run the command of cointeract, that is the cointegration regression equation will be estimated using the fully modified order least square. If I click this enter button, I will get the result of the fully modified order least square. As you can see, this is what we have estimated, fully modified order least square, and these are the results. Time is here having its coefficient, though it's not statistically significant, yet it is positive. The other two variables, that is the capital to labor ratio, they are desirable in terms of their statistical significance, as well as they have positive signs, so they have a positive relationship with the output, the natural log of it. This is the intercept, which is positive, and R square is also there, which is desirable. So now we can revert back to our function and substitute these parameters so that it becomes more visible after estimation. So you can see that we have substituted these values. We are trying to recall this form that we have. This is the form that we developed, and here you can see we are substituting those values. The value of natural log is this, and when we get rid of this natural log, we will raise it to Euler number, that is natural exponent, and then the value of a will be extracted, which is 39.939. This is the coefficient of t that we found. We also found the coefficient of natural log of capital to labor ratio and the coefficient of capital to labor ratio in its actual form. These are the values that we found, and we have substituted from the Eviews. And this is the other equivalent of this form of VES, in which we do not have the natural log. This is the actual value of Q, and A is already found, as we did a little bit of calculation here from natural log of A, and we found the value of A. Here we have substituted it. The value of the coefficient of time is here, lambda, and alpha is also substituted. 1 minus alpha will be equal to this, and beta was also found, and that was equal to this. So these coefficients have been substituted, and we have been able to find out or estimate the variable elasticity of substitution production function by using this form, which is slightly different from the usual form, but it is estimation friendly, so it is desirable to use this instead of the other form of the VES production function. I hope you have learned a little bit and enjoyed it, so don't forget to like it. Thank you.